Molecules are compounds held together with chemical forces. The smallest type of molecules are going to be diatomic molecules formed with two atoms only, right? But it's possible to have molecules formed of larger and larger number of atoms, and in this case, is going to be called polyatomic molecules with more than two atoms. Molecules are usually made of combinations of nonmetals with each other or nonmetals with metalloids. And sometimes we give them common names that doesn't have any rules of how we name them, like water, ammonia, methane. These are just common names that we came up with. The systematic names will follow a similar approach to type 1 ionic compounds, with the elements furthest to the left in the periodic table and closer to the bottom comes first, and then elements to the top right will come next with IDE at the end. And then we will use Greek prefixes to indicate the number of each type of atoms. If you have one atom of a certain element, it's going to be mono. Two, it's going to be di. Three, tri, and so on, just to indicate the number of atoms of each element involved. The first example is a combination of hydrogen and iodine. If you look at the periodic table, you will find that hydrogen is indeed further to the left with respect to iodine. So that's why the name will have hydrogen first. So it's hydrogen, followed by the name of the other ion, which is going to be iodide with IDE at the end. And in this case, we actually don't need to use anything to indicate the number of each element because there are no other possibilities. So when I say hydrogen iodide, it's understood that it has one hydrogen per one iodide. There is no other combination. Second example, however, we start again with the atom or the element further to the left, which is in this case nitrogen, followed by the other element, which is fluoride with IDE at the end. But we use Greek prefixes, in this case tri, to indicate the number of fluorine, because combinations of nitrogen with fluorine could form other combinations like N2F4 and so on. So you have to use Greek prefixes in this case to indicate the exact number of each element atoms in the combination to differentiate it from other possibilities. Same thing here for sulfur. Sulfur is further to the left, so it comes first, so it's sulfur. And then oxygen comes next with IDE at the end, so it's oxide. However, we need to indicate that it's two oxygen atoms in the formula, so we will use di, so it's sulfur dioxide. Again, that's to differentiate this specific molecule from other possible combinations like sulfur trioxide, for example. Nitrogen is further to the left, so it comes first, so it's nitrogen. And then chlorine comes next with IDE at the end, so it's chloride. But we have to use Greek prefixes to indicate that it's two nitrogen and four chlorides. So dinitrogen tetrachloride. And that is going to be very obvious when you compare these two examples here. The same type of elements are combining in two completely different combinations with two completely different molecules in nature. Nitrogen is further to the left, so it's it comes first, so it's nitrogen, and then oxygen with IDE at the end, but we have to use Greek prefixes to indicate that we have two oxygen ions, two oxygen atoms. In the second example here, it's actually dinitrogen oxide. Naming compounds will depend on the nature of the compound. We have molecular compounds, which are combinations of nonmetals with each other. And in this case, we start with the element further to the left, using Greek prefixes to indicate the number of atoms of each element in the compound. For ionic compounds, we will have two types. Type 1 will have only one possible combination for the charge of the cation, and in this case, you don't need to add anything special. You just start with the name of the metal followed by the name of the anion with IDE at the end, with no special additions, because there is only one possible combination in this case. Type 2 will have more than one possible charge. So you have to indicate the charge of the metal ion using Roman numerals in parentheses.